In this video, we're going to learn the grammar of ratios. Just like grammar gives structure to language, ratios give structure to the way we compare things in the world. By the end, you'll be able to measure and translate almost any two quantities into a single, meaningful number. A ratio is simply a comparison of the relative size of two quantities. The word per is your signal that division is happening. Ratios translate raw numbers into relationships, allowing us to compare everything from prices to speed. Consider the grocery store dilemma. When faced with two different bundle sizes and prices, it's hard to see the value. We use division to find the unit price, turning those two packs into a simple comparison. The order of division changes your perspective. Dollars per can shows how much you pay for one unit, while cans per dollar shows how much you get for your money. Both reveal which option is the better deal. Think of this as the Rosetta Stone of ratios. Whether written as a phrase, a colon, or a fraction, these are all just different ways to express the same relationship, with the decimal form simplifying it against one. Using this conversion table, we can follow a repeatable recipe. Take the ratio, write it as a fraction, reduce it, and divide to get the decimal. Sometimes you'll need to round your results based on the context. Rule number 1, units must match before they can combine. You cannot fairly combine inches and feet. Use a conversion layer first, then remember, whatever quantity comes first in your description goes on the top of your fraction. Here is a useful shortcut. If both quantities end in 0, you can cancel them out symmetrically. This gives you a smaller, easier fraction to reduce, turning a complex calculation into something much simpler. Rule number 2, equivalence requires perfect scaling. If you look at the aspect ratios of different film formats, you can see visually and mathematically that they do not match. If the multipliers differ, the ratios are not equivalent. Rule number 3, ratios scale symmetrically. For a recipe, as long as you apply the same scale factor to both the numerator and the denominator, the relative balance of your ingredients remains perfectly preserved. Let's visualize the denominator flip with dogs and treats. Depending on which number comes first, the resulting decimal sentence tells a totally different story. The numerator dictates the narrative of the ratio. Applying these rules, we can quantify inequality in hourly wages. By setting the ratio, reducing the numbers, and converting to a decimal, we find exactly how much one person earns relative to another's dollar. Ultimately, a ratio is not just a fraction, it is a lens. By choosing which quantity sits in the numerator, you control the story the data tells. The math is objective, but the perspective you choose is yours.